Hello, so my name's Steven, and I'm making this quick video to demonstrate this web application I created, which models the spatial spread of a contagious disease. So to get started, I'm going to click Reset, and then I'm going to click Run. And so if I scroll down, what I have here is on the left, there's this infection distribution chart. So this is showing at different locations the percentage of people who are infected. So a redder area means more infected people, bluer means fewer infected people. And then on the right, I've got this population distribution. So what's happening is there's this built-in system of 400 nonlinear differential equations that's being solved by this application. People are moving around. They move to high population areas more often than low population areas, so that's affecting how things are spreading. And initially, you don't have many infected people, so there's not a lot going on. But gradually, it gains steam, and big differences start to show up. And that's what you're starting to see here on the left. You can see that a lot of these squares are turning red, or at least purple. And so that's indicating increasing percentages of infected people. And it's spreading in a very uneven way because, again, people move around in a way that depends on population density. So this is something that researchers have found by looking at a lot of different data sets. And it makes sense intuitively, I think. People travel to cities more often than they would to sparsely populated areas. So now to pause it, I'm going to click Stop. And now I'm going to show you what happens if you change parameters. So the effective transmission rate is telling you how much the disease spreads. So if a typical person's infected, this is going to tell you the number of people that you can expect them to spread the disease to. So if, for instance, policymakers do things like enforce social distancing guidelines or have people wear masks or maybe have people stay home from work when they get sick, that's going to lower this parameter. So I'm going to click this minus button here. And so that's lowering the parameter value. And another important parameter is this recovery rate. So if people get access to better medicine, better medical care, things like that, they can recover more quickly. So I'm going to increase this. And then I'm going to resume the simulation. So I'm going to click Run again. And what you see here is now instead of everything turning red, because I changed those parameters, now the dynamics have changed and things are actually fading to blue. Okay. In other words, the disease is dying out. The epidemic has been stopped. And so there are lots of different parameters in this model that you can play with, but this gives you just kind of a basic demonstration of some of the science behind modern epidemiological models. So that's it. Thank you.